Your so for 240, your test is going to be somewhat similar to the third semester test. You just might have a few nuanced questions like one of these, where you are converting this infusion rate, micrograms per kilogram per minute, to milliliters per hour. And so I'm going to go ahead and I'll start with that question because that's a good one for you to see. If you are looking at the review that's available on the OneDrive folder, you can get what you want to work on or look at is the Boyce folder as well as the Allegheny folder, because there's going to be a little bit of overlap with both of those classes for you. So just keep that in mind when you're looking at some of these things to that you can access the Boyce folder. And then the Boyce, there's a 230 review that I think would be also helpful for you to look at. Again, it's in the Boyce folder 230, but I think there's a lot of questions in there that will apply to you at North. So let's go ahead and let's look at this question for the dopamine infusion. So this is on your blueprint. It probably says something like convert micrograms per minute or milligrams per hour or something along those lines. And you're essentially going to be doing that in this problem as well as in the other the 230 practice. There's some more problems just like this as well. And then this is the 240 review for or the 240 orientation packet for Allegheny campus. So you see where I'm getting this from. So all right. So the 5 micrograms per kilogram per minute is what's been ordered. You have a patient that weighs 70 kilograms, and then you have available 400 milligrams per 250 ml. So basically what we're going to do is we're going to convert micrograms to milligrams, minutes to hours in order to get our infusion rate. Now you should know at this point that when they say infusion, they mean one of two things: milliliters per hour, or they mean drops per minute. And how we know that this is milliliters per hour and not drops per minute is there's nothing indicating any kind of drop factor, no tubing, nothing is listed there that would indicate drops. So that's how you know that you're not dealing with drops and that you're going to deal with milliliters per hour. So I'm going to show you how I would solve this. If you do this a different way, as long as you're getting the same answer, the right answer, then you're doing it right. Okay. So the first thing I'm going to do is I'm going to count for the patient's weight. I'm going to take the patient's weight at 70 kilograms times the 5 micrograms per kilogram per minute. And what that does is it eliminates kilograms. Okay. And what I'm going to get is 350 micrograms per minute. Now I want to ask you, do you have to do your setups as like just one long thing, or can you chop it up like I'm chopping it up? Because I know North might be a little bit different as far as what you're required to do.
We normally do a whole thing. We don't normally split it.
Okay. Then let's do it your way. All right. So if I'm going to do this the full way, we're going to piece this out. So I'm still going to start with the patient at 70 kilograms. Okay. We don't need to convert pounds to kilograms because it's already in kilograms, but we're still going to multiply by the 5 micrograms per kilogram. Now, per minute, sorry. Now, you might do this differently, but I would recommend right off the bat converting minutes to hours. In reality, it doesn't matter because you're doing this all as one long thing, but you got to make sure you account for these things. So I'm assuming you cross things out. Now, this is in micrograms, this is in milligrams. We need them to both be the same. So since we're in micrograms here and we're working towards milligrams, I think it's a good idea to go ahead and convert micrograms to milligrams at this point. So you should know that there are 1,000 micrograms in a milligram. And I know you might write this out just a little bit differently than I am, but bear with me. So now we've gotten rid of micrograms, we've gotten rid of minutes. We're now in milligrams per hour based off of what we've written out here. The next thing is to incorporate our infusion or our IV, and our IV says that we have 400 milligrams for 250 ml. And if I did everything right, I should be left with just milliliters per hour. And all I'm going to do is multiply across the top, multiply across on the bottom, and then divide. And I'll even tell you, you'll hear me say how I do this. I'm going to open up my calculator. 70 times 5 times 60 times 250 divided by 1,000 divided by 400. One second, I typed something in wrong. 70 times 5 times 60 times 250. Oh, okay, that's where I was missing a 0. Divided by 1,000 divided by 400. And then you'll get an answer of 13.125. And you would write that, you would round that to the nearest tenth. So 13.1 mil per hour. So I will say this, if I tried to do what I just did there for Allegheny campus, I think they'd have a hard time with it. So I'm glad that that's how you've been taught. I think that's a good way, but if you chop it up, it's not a big deal either. You can still get to the same answer, but I wanted to do what was comfortable for you. All right. The other types of questions that are usually missed or at least questioned are going to be things like this, where there's extra information that you don't need. So it tells you you have a patient with congestive heart failure, ordered furosemide 200 milligrams IV daily, available as 100 milligrams IV, and then it says the label reads 30 milligrams per milliliter. So this is almost like a reconstitution type of question. And then it says, how many milliliters of the drug will you give? So I don't actually need to worry about this. I just need to know what was ordered and what I have available. So you would just do 200 over 30 and you would get your milliliters, which is 6.7 milliliters rounded. All right. Let's see here. This is another question where there's extra information. It's asking you to calculate a flow rate. Now, for you, it might not say, it might not say what is the correct drops per minute flow rate. It might just say what is the correct drop flow rate or drop rate or infusion rate. The clue that you're going to be doing drop rate, drops per minute, is that it gives you a drop factor. Okay. It gives you a volume of 120 milliliters over 30 minutes. It also tells you it's Solu-Medrol 200 milligrams. Many students try to incorporate the 200 milligrams into their equation, but it doesn't tell you. You don't need that information. That doesn't help you answer the question. And the reason being is that just tells you the strength of the IV, but the question is, how fast is the IV infusing? We want to know more than that, then we would need to add more, or then we would ask that question, but we don't. We just want to know the infusion. I did see that someone else joined in. If you didn't already, please put your name and the campus that you are that you're from in the chat, please, just so I can keep track of attendance. All right, so some of the things that you're going to see that hopefully you've looked at, and I'm imagining if you can do the long, drawn out dimensional analysis, you should be fine with a lot of these. But most of these questions that are kind of new or nuanced that sometimes are challenging for students is these units per hour to milliliters per hour. So these are like your heparin, your insulin infusions, and if you've been doing this using dimensional analysis, then this should be okay. This is usually just a two-step process of converting units per hour to milliliters per hour. And you'll know you've done it right because you can eliminate these. This actually makes these reviews go so much easier knowing that you know how to do dimensional analysis, I'm assuming. And I'm just double checking. 750 times 1,000 divided by 25,000. It looks like we get 30 milliliters per hour. Now at Allegheny campus, they're going to get this monstrosity of a heparin protocol, but I'm going to show you what you'll likely see. And again, this is in the 230 review. So if you go to the OneDrive folder, go to the Boyce folder, go to 230, and you'll see it'll say Dosage Calc Study Guide. And then, of course, I'm going to pull it up for you here. Once it loads up, there we go. I'm asking a lot of my computer today, apparently. All right, so this was actually put together by a Boyce student. Her name is Maddie. This is also good just in case you need to review some of the other conversions that you need to know. She actually did a good job of breaking down, you know, 1 or 2 step like method as far as breaking these down. But I want to show you what you'll see as a heparin protocol question. If you get a reconstitution, there's an example of reconstitution there. All right. So for heparin, and then I'll work this out the long way. That way you have it written the way that you're used to seeing it, as opposed to, I chop it up just to kind of create like little breaks and stop points, but obviously you don't need to do that. Great. So for this, and let's just change this up a little bit. So instead of 110 pounds, let's make this individual for this purpose. Let's just make them 175 pounds. Okay, we'll just change it up and we'll use a different variable. So for the heparin protocol, and I think you had this last semester and third semester, you should remember that the protocol just tells you to do 2 things. It tells you to bolus the patient with a weight-based bolus, and then it tells you to start them on an IV drip using a weight-based IV infusion. So the initial bolus is the 80 units per kilogram, and then the infusion rate, you start at 18 units per kilogram per hour. The other pieces of information you need to know is it's going to ask you to calculate how much to administer bolus, and you want to know how much that is in milliliters. So you need to know the bolus dose strength is 1,000 units per milliliter. And you need to know that you have, for your infusion, you have 25,000 units in 250 ml. So basically it's like 2 questions built into one. At Allegheny campus, they'll get asked both these questions. It'll count as one question. I don't know if that's the same for you guys or not. So for this question, I'm going to put this together for the bolus and for the infusion rate the way that I think you're used to doing it. I'm going to start with the patient's weight. What did I say? 175, right? So we're going to say this patient is 175 pounds. So step 1, I want to convert pounds to kilograms. And again, if you just draw a big straight line across, it's perfectly fine. So I'm doing the same thing essentially. Now that I've converted pounds to kilograms, the next thing I'm going to do is account for the bolus, which tells me 80 units per kilogram. Then I'm going to account for getting rid of or converting units to milliliters using the bolus dose strength of 1,000 units per milliliter. I'm going to type that into my calculator. 175 times 80 divide by 2.2 divide by 1,000. And I'm going to get 6.36 repeating. So my answer would be 6.4 milliliters. I'm going to do a similar process for the infusion. So again, same patient, same weight. Instead of the bolus dosage strength of the 80 units, I am going to do now 18 units. And that's kilograms per hour. So we got rid of pounds, got rid of kilograms. And then I'm going to do what I did in the previous question that I went over, converting milliliters per hour or units per hour to milliliters per hour. And we're going to use what it tells us we have available. We have 25,000 units. We have 250 milliliters. Again, canceling those out, we're left with what we're looking for, which is milliliters per hour. So I'm just going to take my 175 times 18 times 250 divided by 2.2 divided by 25,000. And I will get 14.31818181, so 14.3 milliliters per hour. So this is how I think you will see your heparin type question. Notice it says 4 questions. So she actually had put together a couple variations of questions. I did solve these a little bit differently, but as long as you get to the same answer, you're doing the same thing I am. This will be good practice. And then I wanted to see there's she also has some of those in weird infusion. So here's like a nitroglycerin type question where it's telling you, you know, you have 20 micrograms per minute, but you want to know how many milliliters per hour. And so you can do this. And obviously you see that I did it stepwise. You can do it all as one long thing. As long as you get the right answer, the 6 milliliters per hour, then you're doing it the right way. And then if you have a question on that, just let me know and I can show you. All right, so those are the major things that most often that most fourth semester students struggle with. But if you have any questions you want to see, work through, or if you have any other questions, just let me know. You can, like I said, just type it in chat or just unmute and let me know. All right, and if you don't have any other questions, you know, like I said, just I would look through these reviews. And like I said, this is in the Boyce folder. It's the 230 study guide, but it's applicable to 240. So you can see the one that's marked 23 spring, I've marked in. If you want it fresh and unmarked, just pull up the one that doesn't say 23 spring, and that should be good.